Good morning, class. How are you today? So this is the recorded video lecture for the Module 5 in InBt121. So may I greet you a Merry Christmas. Now, yeah, it's already, Christmas is coming, and of course, um, you are with your families, and we thank that that's the advantage that we have, that you are with your families, um, as you juggle your academics, no? So and it's very timely that we should spend our time with our families, of course. And for us workers in VS, you have not yet um, gone home um, for me. It's almost 2 years that um, um, have not go home or went home with the family in Cebu. So it's quite napakatagal. But then yeah, there is a time and perfect time for everything, that you can be with our families. So we have to maximize our time with our families, because Christmas is for the family, of course. Yeah, one of that purpose is for the family. And also, another reason is our spiritual being, that Christ was born, and also he saved us from our sins. That is why we celebrate this season, the Christmas season. So Jesus is the reason for the season. So that's why I want to encourage you to fight more, because even though that the vacation is quite already tempting, and you want to rest because of this cold weather that we are experiencing. So but then you have to strive, because next week will be your final exam, and you have more lab reports to accomplish, to submit. And yeah, just keep on fighting and keep the faith, huh? So, may I remind everyone, for your lab reports, your learning tasks, please accomplish it now, okay? So that's all for my encouragement. So let's now proceed to the topic in Module 5, the media and sterilization and the fermentation. There are two lessons that I have to discuss here, but I'll be sending another video lecture for the lesson 2. But I will focus more here on the lesson 1, the media in the industrial process. No, because we are talking about the fermentation, the different types of fermentation, the different types of bioreactor, but we have not yet dwelled more on the the nutrients or the needed requirements for the microorganisms to grow, and then also produce the right kind of um, to produce this kind of biological products that are really important, and how the biological product are produced using the substrate that we use. Of course, microorganisms are really important, and the requirements are really critical in order for them to sustain their physiological metabolism, and also in order for them also to grow and multiply. So they can really produce the enzymes or the secondary metabolite that are really economically useful for the large production of these kinds of products. Okay, so this is the pre-test questions. These are the pre-test questions that you have to answer in your own words. And I have to, this is not graded class, but I want to stir up your critical thinking skills, your mind. So, in your opinion, what is the importance of culture medium in the fermentation? And second, give some examples of the basic requirement for a microorganisms to grow. I'm sure that you are familiar with this because you have already taken the microbiology 22, right? And also, um, it is already discussed primarily sa BTEC 22, BTEC 21, so you have all the knowledge. So you just have to input all the base knowledge that you know. Okay, so let us now proceed. So for the learning outcomes class, you have to know the importance of culture medium in the fermentation process, to determine the different composition of medium in the industrial process, and the last one is to understand the role and function of each composition of the medium in the fermentation. Now, class, there are many factors that should be considered in order to choose the right kind of nutrients for the microorganism. No? So it really needs a detailed investigation for the establishment of the suitable medium. So that is why sa fermentation process, sa media class, na siya gitawag nga optimization, because you have to not just the different kinds of nutrients that are needed, but also the levels of the concentration of the nutrients that you have to feed for the microorganism. You have to establish that, diba? So certain basic requirements must be met by any such medium. Okay, so all microorganisms require water, source of energy, carbon, nitrogen, mineral, vitamins, and oxygen for those aerobic microorganisms. So these are just the basic requirements, because these are the basic structures, the elements that are needed for them to have their metabolism, in order for them also to degrade such in order for them to multiply, to divide, diba? Most microorganisms they will divide through binary fission. So for their cell cycle, for their DNA replication, and also RNA transcription and translation. So if we want to go deeper in the molecular level, so that's how also the microorganisms work in order for them to grow and also thrive. Now, on a small scale, it is easy to maintain, but on large scale, it's very difficult that it does not satisfy the nutrients or the microorganisms with that when you use proportions. When we say that in this large scale, 100 ml of that medium can really grow the microorganisms, that particular 200 ml. Now, if you want to upgrade this fermentation volume, okay, 200 ml in volume, o tapos you want something like 200, 1000 ml na. So you have to, 100, you have to multiply, the 200, you have to multiply by 5. Then 100 divided by, multiply by 5. But it does not necessarily assure that the same concentration of your biological, or it will double the concentration of the biological product that you want to produce using that ratio and proportion of your medium. So it does not really like that. You have to go back to square one to optimize if you want to upscale your fermentation process, no, in a volume. Okay, so it's really difficult to maintain the satisfactory growth, because it also depends upon the conditions of your microorganisms. On a large scale, one must normally use sources of nutrients to create a medium which will meet as many as possible of these following criteria. So these are the criteria, class, that you have to consider in order to choose the right medium, no? So it will produce the maximum yield of product or biomass per gram of substrate used. So of course, there is the maximum yield per gram. You have to calculate it with how many grams of this product that are used when you feed this kind of nutrients, like that. You have to analyze it and calculate that percentage. Yeah, if it's this gamay ra siya, kung gamay ra siya nga concentration of the substrate, but then it will produce a high amount, that's a good nutrient. That's a good medium to consider for that particular microorganism. So remember, class, that one microorganism does not really necessarily that the medium applies to all microorganisms that will really have a high concentration yield. No, so it varies upon the microorganisms, whether it is aerobic or anaerobic, and also the right conditions, the critical conditions that we have to follow. Okay, mamaya we will really tackle that also. And then second, it will also produce the maximum concentration of product or biomass. Okay, it's still the same way that the maximum concentration of product or the biomass itself after purification. So it will also permit the maximum rate of product formation. Okay, during it depends din kasi your biological product also that if your if your product is produced at the exponential phase, no, so you have to calculate the rate, the product formation, the maximum rate that using a short period of time you can really have a high concentration of your product. So there will be also minimum yield of undesired products, mga toxic waste that can really interfere, that also inhibit the product formation, yeah, by the microorganisms. So you should have to ensure that there will be minimum yield of undesired products. And also, there should be a consistent quality and readily available of the media throughout the year. No? So it does not, it will, hindi siya parang lang, once in a blue moon na, it should be available always, like the corn, the rice, and also those from the sugar cane, molasses, because these are byproducts, so they are really available always once a month, because of course there are many sugarcane industries that are already that are processing. So there's the molasses are byproducts, so there will always be available molasses that can really sustain this that can sustain the fermentation using that substrate. So, ingana na siya, of course. And of course, molasses is really cheap, but really it's high in fructose, high in the sugars that are really needed for the microorganisms, especially yeast, So it will also cause minimal problems during media making and sterilization. There are many complex also media that should be considered, because some might, when we subject to heat, no, when subject to sterilization, it will cause browning, just like the molasses, no. So we have tried that when uh, we have this little species that we use the molasses, and it really forms. Uh, it will cause some browning effect that might interfere the biomass formation of the yeast. So the yeast was our microorganisms back then. So it will also cause minimal problems in other aspects of production process, particularly aeration and agitation, extraction, purification, and waste treatment. So it should have a minimal problem only. Okay, so that's the criteria class of the choosing the right amount of medium. And so these are the specific sources of nutrient sources that are really needed for the microorganisms. And we have also examples of um, uh, sources, carbon sources that can be found in plants. Okay, so the carbon sources are can be found in cane molasses. Cane molasses is what, like I have told you kanina, in cane molasses, sugar cane. You can really because molasses are byproducts, from the sugar industry, can really buy this in higher volume, high in bulk, and also it's quite cheap lang. So as long as it is really near in your area lang po. So here in Leyte, we have this uh, Hisumco. I think ang Hisumco are processing sugars, right? So and also we have that e-pill also that are producing alcohol and molasses is one of the substrates that can be used for the production of ethanol. So that's it. You can also have beef molasses, cereal grains, but cereal grains are uh, it's quite pricey, I think. So you can also have starch, glucose, sucrose, lactose as carbon sources. Okay, so nitrogen source naman class, these are ammonium salts, the nitrates, corn syrup liquor, the soybean meal, yeah, soybean meal, slaughterhouse waste, and also the fermentation residues. You can also have that, but it really depends upon the microorganisms that will uh, be fed. Okay, we should meet the above criteria for production media because they are cheap materials. So it's really advantageous that your substrates are cheap and not pricey and widely available here in the Philippines because if you want to produce it in a large scale volume, so you will never have a hard time finding these sources in a bulk uh, volume or higher concentration that should be fed in your fermentation, right? So, of course, you have to use bioreactor na, but I don't know on, there are bioreactors in VSU, but it's just 1 liter, 2 liters lang, so may 5 liters din, but it's for mammalian cells, so ganun yung ano dito sa for the bioreactor. But in the like we visited the San Miguel Corporation. Yeah, so they are producing alcohol there in Batangas because it's quite near to the Central Azucarera in Batangas, in which they are the source of the molasses. They bought molasses in the Central Azucarera in Batangas, and then they will use it for the production of ethanol. So they have a large bioreactors there, as in ang pilot scale, ang pilot plant there. These are really large. That of course you have to ano pa go you have to use a ladder in order to go up and then visit this bioreactor. So there are many sophisticated instruments that can be found in the pilot in the alcohol industry. No, so use we have to use simpler procedures also and select suitable sporulation and inoculation media. No? So that's one of the things also that we have to consider in the uh, higher yield of your biological product. So, of course, the medium selected will affect the design of the fermenter. Yes, because so if it's submerged fermentation, you have to, of course, powderize your substrate, and also you have to you have to powderize it, and also you have to process it then. And if you have the solid state fermentation, you can also um, you can shred it, ganun. So, yun lang yung kailangan nating ano. So, um, in the fermentation naman sa wine, here in root crops, so root crops are really the substrates that are used there in order to produce wine, the alcoholic beverages. So usually minor root crops, like for example, the gabi, the yam, yeah, the cocoyam, these are used in order to produce wine. So microbial oxidation of hydrocarbons is a highly aerobic and exothermic process. Thus, production fermenters should have a very high oxygen transfer capacity with excellent cooling facilities. No? So because these are exothermic process and it will produce heat, right? So it is really expected that the temperature will go up high, will increase. So there should be a very high oxygen transfer and also excellent cooling facilities because of course it might break the bioreactor when there are no excellent when there are no cooling facilities. Airlift airlift fermenter design will solve the problem. Next. Okay, so there's a problem in the developing a process from the laboratory to the pilot scale and subsequently to the industrial scale must also be considered. Okay, so the lab medium may not be ideal in a large fermenter with a low gas transfer pattern. And also, a medium with a high viscosity will also need a higher power input for effective steering because we want to, the purpose of the steering is to distribute evenly the medium so that there will be equal access of the in the microorganisms, right? So if the medium is highly viscous, of course, uh, the input for the steerer, for the it should be adjusted. It should be increased, so that there will be no it will not kind of dili gan siya lapot kaayo, and then there will be equal distribution of the medium in the microorganism. Okay, so these are also important factors, the pH variation, the foam formation, the oxidation reduction potential, and the morphological form of the organism, and also the metabolic inhibitors. The medium also will affect product recovery and effluent treatment. So, during na siya sa purification. There are undefined complex natural materials that are used also. So they are cheaper, but it produces unpredictable biomass yield problems. So they are inconsistent in their yield, because they are undefined. When you say undefined, when it is not that really purified, like the molasses, no, these are byproducts. So it does not only contain fructose, but also contains many fibers because of the gikan na siya sugar cane, so it's not really that purified. So there are many other residues, other chemicals that containing with that molasses that are with that molasses. So yun ang problem for the undefined complex materials. Okay, product recovery is also very difficult, and residual components may interfere with the recovery and contribute to the biological oxygen demand of the effluent. So because of that, these are undefined complexes like the molasses. These are cereal grains. So naiubag din yung mga technical and laboratory grade that are really purified, that only glucose lang siya, percentage of glucose, but they're really pricey. That's the cost also in return, that if you want to have a purified na mga medium that we can use for large scale, your production cost also increase. And in return, also your biological product will also be quite a lot pricey. Okay, although defined media is more expensive, but it gives more predictable yield than a defined media. All right. And also, molasses would normally, for example, the molasses would normally be used as the cheapest carbohydrate to grow yeast biomass in large scale process. Okay, but this is not acceptable for recombinant protein production because of difficulties and cost of purification. You'll be having a hard time for the purification process, no? So if you want to siguro dili siya high degree impurity sa nga enzymes and so also biomass, so pwede na. But if you go to use molasses, then that for the high concentration of this for the um for the high degree impurity biological products, then you will having a hard time in the purification process. Okay, so let us now define what is a defined medium, right? So glucose, sucrose, animal salts, trace elements, pure vitamins, and ammonium as nitrogen source, and for pH control is used as anti-foaming agent. So these are a defined medium class, no? The glucose, sucrose, the animal salts, and trace elements. Okay, so we can really purchase this from different chemical industries. So it's really purified but quite pricey. Okay, so another next For the medium formulation class, so it is really an essential stage in the design of successful laboratory experiment. Okay, so it is really important because you will have a benchmark of your and how the microorganisms will produce this. Nakasalalay dito ang microorganisms that will really produce your biological product. So the constituent of the medium must satisfy the elemental requirements for cell biomass and metabolite production. So this is the equation for the um, fermentation, no? So the carbon, you have nitrogen, you have oxygen also. So what are the carbon source, the nitrogen source that you have to feed the microorganism, and also the oxygen, it's aerobic, so another requirements. And you will produce the biomass, the product, the carbon dioxide, and also water, and also heat, no? So that's it. Okay, so this equation should be expressed in quantitative terms, which is important in the economical design of media if component wastage is to be minimal. So we have to calculate the minimal quantities of nutrients which will be needed to produce a specific amount of biomass, and it should calculate substrate concentration necessary to produce required product yields. So we have here some scientists or researchers who investigated the nutrient requirements for certain microorganisms. Okay, so in Coney 1981, which is quite a long time ago, some nutrients are frequently added in substantial excess of that required, like the phosphorus, the sodium, and some trace elements. So these are really needed as cofactors. As what I have told you that some enzymes need cofactors in order for them to function in their metabolism. So it is deliberately raised in many media to increase the buffering capacity also. It depends on the medium design. So there are some microorganisms that cannot synthesize specific nutrients like the amino acids, vitamins and nucleotides. So there should be a growth factor that should be identified and added into the medium. The carbon has a dual role in biosynthesis and also energy generation. So for the ATP, for the function, metabolism, and also the energy generation, the citric glycol, no, the glycolysis, and also the um, electron transport chain, yun, para sa microorganisms. So, carbon requirement for biomass production under aerobic condition may be established as the cellular yield, or Y, which is defined as the quantity of cell dry matter produced over the quantity of the concentration carbon substrate utilized. So, um, kung under aerobic siya nga condition, so it should be aerobic, meaning there are oxygen that are really incorporated into the medium. So the cell dry matter, okay, that are produced, the biomass after the fermentation, no, over the quantity of the carbon substrate utilized, no. So kana siya ang imong kinahanglan nga kuan utilized nimo under the cell dry matter. Of course, in order to calculate that, you have to subject the biomass into like you have to dry it using on oven. Of course, you have to, and then also the quantity of the carbon substrate utilized, of how much concentration you have inputted or you have fed into the medium in the mix of the media. Okay, so for the oxygen, it is really for the aeration of the culture, and the design of the medium will influence the oxygen demand of a culture, in that more reduced carbon sources will result in a higher oxygen demand. Okay, so if ang carbon sources imo i-decrease, i-concentration, there will be higher oxygen demand. Okay. For the water class, it is the role of the water or the function of it is to for the heating, yeah, and then also for the cooling and cleaning and rinsing. Okay, it should be required in a large quantities for the pH also, no, because since most of the fermentation are in a submerged condition, submerged fermentation. So we needed water in order to mix the media, no, in order for them to be well distributed in the media. And it is in a liquid form, quite obvious for it's water. So dissolves in order to dissolve salt and also for effluent contamination. So mineral requirement of water is very important in brewing and most critical in the mashing process. So I will not dwell with that. So let's go on with the energy sources. Energy comes either from oxidation of the medium components or from the light. Okay, so most industrial microorganisms are chemo-organotrophs, which is they needed light and also carbon sources in order for them to uh, metabolize to function in their metabolism. And the most common source of energy will be the carbon, CHO, right? Lipids and proteins. Okay, and there are microorganisms that also use hydrocarbons or methanol. Yeah, diba? As carbon and energy sources or methane. Yes. So it depends, 'di ba? Maraming microorganisms na ganon that are thriving in the most extreme environment, you know. So they also need the extreme substrate in order for them to survive. So for the carbon sources, these are the factors that influences in your choice of the carbon source, the carbon source. Number one, it should be that the rate at which the carbon source is metabolized can often influence the formation of the biomass or production of primary or secondary metabolites. So in order to identify this, you have to play around many carbon sources and you have to use a statistical design in order to determine the rate of your carbon source for the product formation, for the biomass formation, like that. And also second a factor is the fast growth due to high concentration of rapidly metabolized sugars is often associated with low productivity of secondary metabolites. So that is you have to do with this fast growth uh, because of the rapidly metabolized sugars. Okay, so another is that these are the carbon catabolite regulation of metabolite biosynthesis. So these are the metabolites that are produced by these microorganisms, and these can interfere in the production of the metabolites. So glucose, there are many interfering carbon sources. So it should be that when you use this medium, when you choose a medium, it should be that the glucose is lower lang because it might interfere the metabolite production because of course there is a high um, metabolizing sugars, and of course since it is secondary metabolite and it will produce in the during the stationary phase until the death phase, no, so kailangan hindi siyang maraming glucose na i-feed nyo. You have to consider that. Okay, some use less readily metabolized sugars. Okay, so like the lactose, but many processes need continuous or semi-continuous supply of sugar. And also the products uh, that are formed depend on the choice of the carbon source. Okay, so in the industrial process, you have to identify alternative carbon sources in order to have a optimized yield of your uh, biological product. And also, It also depends upon the purity of the carbon source that may affect the choice of the substance. So there may be interfering substance also, no, sa imong carbon sources like the molasses. So you have to consider that. You have to um, you have to consider the purity of your carbon or your um, nutrients or media. So, okay, so another consideration that you have to do is that in the preparation of the media, yeah, of course, we are dealing with aseptic technique in the fermentation process. You have to undergo the medium. You should undergo the sterilization process. So during sterilization, there are two kinds of that. You have to dry sterilize. You just have to plug it in you have to place it in an oven sa mga materials. But then for the medium, you have to it should be placed in the wet sterilization sterilizer yun siya. It will be subjected to 15 minutes in 121 degrees Celsius. Ganun. So other media class will produce a browning effect because of the high concentration of carbon. So, na siya interfering substances na kaning brown compound because of the heating process. So, that is why other method that they use class is that they separate the sugars like glucose, and they have to use the microfilter process. You have to filter it in order to get rid of the possible viable cells that can really interfere, can really contaminate the glucose. So there are particular uh, there is a particular size, four size for that for the microfilter. Yeah, so it's kind of you have to take time in really filtering your media. Okay, so that's for the laboratory um experiment. But if you have to do it in a large scale, you'll be having a hard time. But I guess that there are many microfilters also that are uh, already available in the industry that might help in the sterilization of the carbon source. Okay, uh, so it is best to sterilize the sugar separately because they may react with the ammonium ions and amino acids to form black nitrogen compounds containing which will inhibit the growth of many microorganisms. And if you use starch, it will then be gelatinized and give rise to very viscous liquid. So if you use starch, no, so the choice of substrate may also be influenced by the government rules. So there are also, I know, certain rules that have to be followed. The beet sugar and molasses is encouraged. Now, for the Scotch malt whiskey may be made only from the barley malt, water, and okay, for carbohydrates, its common practice is to use CHO or the carbohydrates in microbial fermentation. And the example of this starch from maize grain because it is cheap and readily available in the Philippines. And also you can have it found, you can found carbohydrates also. You can use carbohydrates also in cereals, potatoes, and cassava. So the hydrolyzed cassava starch is used as a major carbon source for the glutamic acid reaction. That's it, the beet yeah, MSG. Okay, so the syrups produced by acid hydrolysis may also contain toxic products, which make which may make them unsuitable for the particular processes. So we should ensure that toxic products are minimal in the medium that should be used. Okay, and the sucrose also can also be obtained from sugar cane and sugar beet. Now, uh, many there are common. It is commonly used that they use or we use the impure form as wheat or cane molasses. So because these are byproducts from the sugar industry, so these are residues left after crystallization of sugar solution in sugar refining. So that is why it's very impure and has a low degree of purity. So you will have a hard time purifying this for the downstream processing, okay, the biological product itself. Now, molasses is used in the production of high volume or low value products such as ethanol, single cell proteins, organics, and amino acids, and some microbial gums. So it is not really that recommended for the production of enzymes of such particular metabolites because it's very, molasses are very impure. So you'll have a hard time or laborious time to extract or recover and purify your biological products when you use this molasses. So these are the carbohydrate composition of barley malt. No, so the starch, sucrose, reducing sugars, other sugars, hemicellulose, and cellulose. Okay, so it is quite, it is really, it's really, can be analyzed containing this product. Okay, so these can be used in higher value or low value products. So can be used in antibiotics, special enzymes, vaccines, and fine chemicals. But remember that will have a hard time or laborious process during the purification and recovery. Okay, this molasses-based fermentation often need a more expensive and complicated extraction, purification procedure to remove impurities, and it will make the procedure costly. So another byproduct is the corn stick lacquer after starch extraction from maize. So it is used primarily as the nitrogen source. It does contain lactic acid and small amounts while reducing sugars and complex polysaccharides. So we can also use soya bean for the source of nitrogen. So it contains a small but significant amount of CHO. Okay, so these are the composition, the partial analysis of corn stick lacquer. You have many lots of vitamins there and also minerals in uh, the nitrogen and amino acids that contains the corn stick lacquer. So we can also use oils and fats, as nutrients. For so let's um, let us know so what are the functions and roles of oils and fats. So oils, do you know class that oils were first used as carriers for anti-foams in antibiotic class. Di ba class kay naamay naadjay on the fermentation process, so foaming is really evident there because of the input of the oxygen there and also the stirring effect. So mostly they are really um good foaming event diha sa kanang uh, sa fermentation process. So it is used as an anti-foam, no? In order for that to minimize these bubbles. Okay, vegetable oils may also be used as carbon substrates, particularly for the content of the fatty acids, the oleic, the linoleic, and linoleic acids of competitive, which are competitive with this carbohydrate. So, according to a certain researcher, Badger in 1984, so the factors favoring the use of oil instead of the carbohydrates that can be used as carbon source, right? Diba? So it contains approximately 2.4 times the energy of glucose on a pair weight basis. So it has also a volume and advantage that would take 1.24 decimeter cube of soybean oil to add 10 kcal energy to a fermenter, whereas No, for the glucose, it would take 5 decimeter cube of glucose or sucrose, assuming that they are being added in a 50% weight by weight solution. So in the oil class, you just have just put a minimal concentration because of the content of the carbon in the oils and fat. Diba? It's really, you have in the sa oils, kaya there are many triglycerides there, and we have many carbon source, carbon and nitrogen, no? So that is why it just only um, can have that volume of 1.24 decimeter cube of soybean oil that must be added in the fermenter to add a 10 kcal energy. Okay, so in any fermenter, a maximum working capacity is really ideal. Okay, so the oil-based fed batch fermenter allows this procedure to operate more successfully. So again, it has anti-foam properties and which make this downstream processing simpler. Okay, example of this oil is the glycerol uh, triolate that is known to be used in some fermentation which substrate purity is an important consideration. Also, the methylolate has been used as the sole carbon substrate in cephalosporin production. Now let us now go to the nitrogen source. Okay, so most industrially used microorganisms can utilize inorganic or organic source of nutrients. Inorganic nitrogen may be supplied as ammonium gas, uh, nitrate gas, or ammonium salts or nitrates. Okay, ammonia gas or ammonium salts and nitrates. So the ammonia has been used for pH control and as the major nitrogen source in a defined medium for the commercial production of human serum albumin by yeast. So this is the major component of uh, the medium that for the production of human serum albumin. Okay, so the ammonium salts will produce acid conditions and normally cause an alkaline drip. So it will make the pH alkaline. So asa man dapat mo ko ang pH mo increase ang pH or mo low ang pH. So kung may tag alkaline drift mo increase ang pH, 'di ba? Above 7, right? Or 4, 5, 6, 7 padung siya alkaline basic na gid siya. Ingana. So when the ammonium ions has been exhausted, there is an alkaline drift as the nitrate is used as an alternative nitrogen source. So in the presence of nitrate, the assimilation of ammonia is inhibited at pH 2.8 to 3.0. Now, when there is nitrate assimilation, it will continue until the pH has increased to allow the ammonia assimilation mechanism to restart. So, mataas na siya 3.0, 4.0, sa amo na siya. Mo na siya ang ano. So, organic nitrogen may be supplied as amino acid. So, pH should be controlled in this matter. Good po, no? So, the organic nitrogen must be supplied as amino acids, protein, or urea. So, there are also proteinaceous nitrogen compounds that can be sources including corn step liquor, soya meal, peanut meal, and cottonseed that has really a high concentration of nitrogen compounds. Now, in storage, these products may be affected by moisture, temperature, and aging. So these are the best nitrogen sources for some secondary metabolites. Okay, so these are the factors also that influences the choice of the nitrogen source. So first is the control mechanism by the nitrogen oxide reductase. That is, these are the enzymes involved in the conversion of um, nitrogen oxide to ammonium ion. Okay, Sorry. Okay. So in Aspergillus nidolensis, the ammonia also regulates the production of alkaline and neutral proteases. So, however, in antibiotic production, so many microorganisms are influenced by the type and concentration of the nitrogen source. Okay, and in also in the antibiotic production, the production is really inhibited by a rapidly utilized nitrogen source. So particularly, so in the antibiotic production, it only begins to increase in the culture broth after most of the nitrogen consumed. Diba? As you can see that, as you already know that antibiotics are what? These are secondary metabolites. So since nitrogen are really needed for the metabolism of in the primary metabolites in the exponential phase, so the antibiotic production will only begin to increase when when the nitrogen compounds are consumed. So it's just like that. No, may nga nagdid ay ang kuan sa antibiotic production, and these antibiotic production are just produced later in the stationary phase and in the death phase. You know? So there is really exhaustion of the nitrogen source. Okay, so there are many examples that are just in the antibiotic production, but also in the polyene antibiotic also. And this gradual breakdown prevents the accumulation of ammonium ions and deficient amino acids. So they are also complex nitrogen material that cannot be utilized by a microorganisms, and it will create a problem in downstream processing and effluent treatment. So these are the important factors in the final choice of the substrate. So there are many case-to-case basis, like the in the antibiotic production, in the the reductase must be considered, and also there are complex nitrogen material that cannot be utilized by the microorganism. How about the minerals? The function of the minerals is for growth and metabolism. These are cofactors that help the enzymes in order to function in their metabolism, in order for them to divide for the cell cycle. Okay, all microorganisms require certain mineral elements for growth and metabolism. So the magnesium, phosphorus, potassium, sulfur, calcium, and chloride are really essential components. And you have also the copper, the cobalt, copper, zinc, iron, manganese, molybdenum, and zinc that are also equally important in the fermentation process. No, phosphorus is used as a buffer to minimize pH changes when external pH is not being. So these are critical in the specific processes. Okay, so in the result of Gardner 1950, the calcium salt is used to precipitate the excess inorganic phosphate, so indirectly improve the yield of streptomycin. So this is for the improvement of the production of streptomycin. It also influences the production of bactericin, or then citric acid, ergot, monomycin, novobiocin, oxytetracycline, and so on and so forth. Many antibiotics. So another scientist also reported that enzymes were repressed by phosphate, or a phosphate control sequence has also been isolated and characterized by phosphate-regulated promoter that controls biosynthesis of CanDCB. Okay, so these are minerals that can really control the production of the phosphate. It could be used as an inhibitor, okay, for the production. So there are 9 trace elements that are proved to be critical concentration of which is manganese and zinc are really critical in the secondary metabolism, like the antibiotics. So how about the chlorine? The chlorine does not appear to play a nutritional role in the metabolism of fungi, but is really required in some halophilic bacteria because uh, um, they need a salt concentration higher, salt concentration of the bacteria that needs to produce this kind of antibiotics. So other chlorine-containing metabolites are caldromycin, nornidolene, and molicin. So these are trace elements influencing primary and secondary metabolites. Now, how about the chelators? So many media can be prepared or autoclaved without the formation of the visible precipitate of insoluble metal phosphate. No, the problem of insoluble metal phosphate may be eliminated by incorporating low concentration of chelating agents. So these are EDTA, citric acid, and polyphosphate. So that it will dissolve, the phosphate will be dissolved. Okay? So na siya para naa siya even distribution kay musing mo mo go down man siya at the bottom ang mga visible precipitate sa media. So, dili na siya ma-access sa microorganisms. So, these are salts. These chelating agents form complexes with the metal ions in the medium. And then the metal ions, they may be gradually utilized by the microorganism. So, it is not, for everyone, chelating agent does not cause inhibition of growth. So there are also growth factors class that are should be supplemented in the fermentation process, such as vitamins, specific amino acids, fatty acids, and sterols, so that it will induce for the production of such particular biological products. So there are many of the natural carbon and nitrogen sources used in media formulation. It contains all of the required growth factors. No? So, in glutamic acid production, the limited concentration of biotin must be present in the medium, and some requires thiamine. So that there will be a shift of the production of glutamic acid. So next is the buffer. Okay, buffer is really important for the control of the pH, so that there will be no drifting of pH. There will be control of pH changes. So the control of pH may be extremely important if optimal productivity is to be achieved. So many media are buffered at about pH 7.4, usually 7.0 or 6.8. So some incorporate calcium carbonate, and phosphate is also part of the mini media that play an important role in buffering. So these are critical in the production of secondary metabolites. Okay, so another class is the carbon and nitrogen sources will also be a basis for pH control as buffering. Okay, buffering capacity that can be provided by the protein, peptides, and amino acids, such as in corn steep lacquer. Okay, so the pH may also be controlled externally by addition of ammonia and also NaOH and this sulfuric acid. There are also addition of precursors metabolic regulators to media. Okay, so we have that, and we also have these inhibitors. No, inhibitors are added to fermentations. More of specific product may be produced. So the glycerol production depends on modifying the ethanol fermentation by removing acetaldehyde. Right. So uh, for this is that you have to remove the acetaldehyde, which serve as the inhibitor in order to favor to the glycerol production. So ethanol fermentation to glycerol production. Okay, inhibitors have also been used to affect soluble structure and increase the permeability for release of metabolites. And that's the main function of the inhibitor. So for the best example is the use of penicillin and surfactants in glutamic acid production. Usually, mga secondary metabolites gini ang enzyme. ang antibiotics. So there are also inducer. Okay, most enzymes which have industrial interest are inducible. Yes. So in order to have a ano kanang sa gene regulation, there are inducer that in order to trigger the gene to express that antibiotic metabolite. Induced enzymes are synthesized only in response to the presence in the environment of an inducer. So example of inducers are starch or dextrins for amylase, maltose for polydinase, and pectin for pectinase. So most inducers which are included in microbial enzyme media are substrate or substrate analogs, but intermediates and products may sometimes used as inducers. Okay? So you have that, or not that and that. They also have that oxygen requirement and have fast metabolism and rheology. Have that anti-foam also, and yeah, I guess you have to read this along so you can have more understanding with the um, media components. So for this learning task class, you have to find one journal article that root crops are used a substrate in biotechnological products. Cite the significance of the study and the significant results. And it's just one page lang class ha. Do not forget to include the source of your paper and limit your answers in one page only. One page lang ni siya class. I will limit this. One page only. Okay, one page only. Okay, thank you so much for listening. So this ends the module 5 in lesson 1, the culture media in the industrial process. I will then send another lecture for the lesson 2, industrialization. Okay, thank you. Thank you so much, class, for watching this video, and I hope that you will prepare your final exam. This will be included in the final exam class, and also your reporting katong sa midterm. So I will include that. Okay. So thank you so much, and have a productive day.